Somewhere in your company's servers, there is a document that perfectly solves the exact problem you are struggling with right this second.
Oh, absolutely.
But, you will never, ever find it because while we have infinite storage, we basically have zero connection.
Right, it's just a black hole.
Exactly. You are probably staring at this, digital mountain made entirely of PDFs, meeting transcripts, messy wiki pages, and endless chat logs.
Yeah, the endless chat logs are the worst.
They really are. And you have all the data in the world right at your fingertips, but no actual way to connect the dots across all of it. So today, we're looking at a design pattern that actually connects those dots. We're doing a deep dive into the Gemini-based knowledge graph.
It really is the ultimate modern headache, isn't it? It's the needle in a haystack problem, except the haystack is growing by gigabytes every single minute.
And you don't even know what the needle looks like anymore.
Precisely. But the architecture we're analyzing today, it changes the fundamental way systems interact with that mountain of unstructured information.
So let's unpack this right out of the gate, because there's a really crucial distinction we need to make up front before we get into the weeds here.
Okay, lay that.
When we talk about a Gemini-powered knowledge graph, we are not talking about a monolithic, shrink-wrapped piece of software.
No, definitely not.
Like, you don't just go to a vendor website, click buy, and, install a knowledge graph application on your laptop.
Right, and that is probably the most common misconception. People hear the phrase knowledge graph and assume it's a specific app with a sleek user interface and a login screen.
Yeah, like opening up Microsoft Word or something.
Exactly. But it's actually a design pattern. It's an architectural method of utilizing a large language model, in this case, Gemini 2, extract, enrich, and mathematically structure your raw data so that other applications can actually use it.
The way I've been thinking about this pattern after reading through the sources is by comparing it to, a commercial kitchen.
Oh, I like that. How so?
Well, in this scenario, Gemini isn't the fully baked cake sitting in the display window. Gemini is the master chef.
Right. You are handing this chef massive crates of raw, unwashed ingredients, your unstructured data, the chaotic meeting transcripts, the 50-page PDFs, and the chef processes all of that material and organizes it into a perfectly labeled, highly efficient pantry.
That's a great way to put it.
And that highly organized pantry, that is the knowledge graph.
That analogy tracks perfectly with the technical architecture. And, if we want to understand how this master chef actually operates, we have to look closely at the assembly line itself.
Right, the prep station.
Exactly. Like, how do we get from that raw, messy text into something a machine can navigate?
Yeah.
That brings us to the very first step, which is the extraction layer.
I mean, you can't just shove a massive company wiki into a database and hope the database just figures it out.
No, it would just break. So you have a document layer where everything comes in, raw text, slide decks, chat logs. But the AI doesn't read the entire server at once.
Right. The very first thing that happens is chunking. The sources mention splitting this data into roughly 10,000 character chunks before the AI even gets involved.
Now, why that specific number? I mean, why not just feed it the whole document? AI is supposed to be super smart now, right?
Well, it comes down to how large language models allocate their attention. If you hand an AI a 200-page manual all at once, its context window gets flooded.
It's just too much noise.
Right. It might grasp the overarching themes, but it will almost certainly miss the passing mention of a critical subproject on page 42.
Ah, I see.
So by breaking the text down into roughly 10,000 character chunks, which is, about a few thousand words, you give Gemini a very manageable, highly focused context window.
So you're forcing it to read carefully, page by page, rather than skimming the whole book.
Precisely. And once the data is properly chunked, it hits the Gemini extraction layer. This is where models like Gemini 1.5 or 2.0 step in. But the AI isn't reading the text to write a nice summary paragraph. It is actively hunting for two very specific structural elements, which are entities and relationships.
Let's define those terms for anyone who, isn't a data engineer. Entities are basically the nouns in your data, right?
Yeah, exactly.
Like people, projects, specific milestones, physical products, or even overarching business concepts.
Yes. And the relationships are the verbs or the connections bridging those nouns together. Things like works at, owns document, reports to, or was discussed in meeting.
Okay, so nouns and verbs.
Right. The AI reads the chunk text and isolates these elements, but it doesn't output them in natural conversational English. It forces this information into a highly structured JSON schema.
Okay, let's pause on JSON schema because that term gets thrown around a whole lot in our source material. If I'm not a software developer, what does that actually mean, and why are we forcing the AI to use it?
Well, JSON stands for JavaScript Object Notation. And without getting bogged down in the coding specifics, you can basically think of it as a universal, lightweight formatting language that machines use to talk to each other.
So it's for the machines, not for us.
Exactly.
Right.
Because human language is messy. It's full of sarcasm, implied context, winding sentences.
My sentences definitely wind.
We all do it. But computers cannot easily parse that. So a JSON schema strips away all the human nuance and organizes the data into strict, predictable brackets and labels.
So it's forcing the AI to be rigid, which makes sense when you look at what it actually outputs. The sources specifically talk about JSON triples.
Right, the triples.
Subject, predicate, object. Honestly, when I was reading this part, it made me laugh a bit.
Oh, yeah. Why is that?
Well, because here we have this incredibly advanced AI capable of writing poetry or like passing the bar exam, and we are literally forcing it to speak in caveman sentences.
Caveman sentences is a funny way to describe it, but yeah.
I mean, if I give Gemini a chaotic, hour-long meeting transcript full of corporate jargon and people talking over each other, it strips away all the fluff and spits out a JSON format saying, Alice owns Project X.
It does sound primitive when you say it out loud like that.
Yeah.
But that caveman sentence, that normalized triple structure, is the absolute bedrock of everything that follows in this architecture.
It's the foundation.
Yes. By forcing Gemini to output strict subject-predicate-object triples, we are translating human chaos into machine predictability. We are turning a winding conversation into a verifiable data point.
Which is obviously necessary if you're building an enterprise system. But this brings up a massive operational red flag for me.
Okay, what's the red flag?
Well, having a bunch of clean JSON triples is great in theory, but what happens when you process thousands of these chunks across millions of documents? You're going to get an insane amount of overlap.
Ah, yes, the overlap issue.
If I process 50 documents, I might end up with 50 caveman sentences about Alice. This leads us to the next phase in the pipeline, which is deduplication.
You hit on the exact bottleneck of early knowledge graphs. If, Alice Chen is mentioned in 10 different chunks across 5 completely different PDFs, the system absolutely cannot create 10 different Alice Chens in your final map.
Right, that would be a mess.
It'd be unusable. It needs a mechanism to recognize that this is the same entity, and it must merge all of those separate connections into a single unified node.
Wait a minute, I have to push back hard on this. I've seen generative AI confidently hallucinate facts.
We all have.
So in a massive enterprise, Alice Chen could easily be 2 completely different people. One in HR, one in accounting, or maybe in one document someone just wrote A Chen or just Alice.
Very common.
Are the sources really suggesting we trust in the LLM's contextual reasoning to handle database deduplication? Because if the AI has a brain fart and merges the HR Alice with the accounting Alice, my company's entire internal mapping is instantly ruined.
That's a huge risk, yeah.
Why wouldn't we just rely on strict traditional database spelling rules?
That skepticism is entirely warranted. And frankly, it's a debate happening in data engineering right now.
Nope.
But consider the alternative.
Okay.
If you rely purely on strict database spelling rules, A Chen and Alice Chen are forever classified as 2 distinct people.
Right.
The system is too rigid. You lose critical, obvious connections because of a minor typo or a colloquial abbreviation.
Mm-hmm.
This is where a model like Gemini is utilized for a discriminative task rather than a generative one.
Wait, what's the difference there? Generative versus discriminative?
Generative tasks like writing an email or writing a poem are where hallucinations happen because the model is predicting the next most likely word in an open-ended sequence.
It's just making things up as it goes.
Exactly. But deduplication is a discriminative task. The AI is looking at a closed set of data and calculating probabilities. Gemini isn't just looking at the string of letters, it's looking at the semantic weight of the surrounding triples.
So it's looking at the neighborhood of data around the name.
Yes, exactly. It uses its reasoning capabilities to compare the surrounding context. If, say, A Chen has a triple connecting her to the accounting department and another reporting to a manager named Bob.
Okay, I follow.
And Alice Chen also has triples connecting her to accounting. And Bob, Gemini mathematically weighs those overlapping relationships. It calculates a high probability that this is the same entity and merges them.
Oh, that's smart.
It is probabilistic, yes. But for unstructured real-world data, It is vastly more accurate than rigid, exact match database rules that break the moment someone forgets to capitalize a letter.
Okay, the distinction between generative and discriminative tasks actually makes that a lot less terrifying.
Yeah.
The context is the glue.
Exactly.
So, moving down our assembly line, Gemini has extracted the data, formatted it into clean JSON triples, and deduplicated the overlapping entities. Now, those millions of triples need a permanent home.
They need storage.
And I know from the architecture breakdown that they absolutely do not go into a standard rows and columns Excel-style spreadsheet or even a standard SQL database.
Right, no. This is where the actual graph in Knowledge Graph comes to life. You cannot store this web of relationships efficiently in a traditional relational database.
It just doesn't fit.
No, you have to use specialized graph storage layers. The sources highlight several specific databases built for this exact pattern, like Neo4j, Cloud Spanner Graph, ApertureDB, SurrealDB, and Nebula Graph.
Let's pick one of those and visualize it, because throwing out 5 database names doesn't really help explain how they work.
Fair point.
If I'm translating the difference between a traditional SQL database and something like Neo4j, well, a traditional database is essentially a giant filing cabinet.
Right, very organized but rigid.
Yeah, it's rigid. You have tables, you have rows, you have columns. If I want to find how a specific document relates to a specific person, the database has to cross-reference multiple massive tables using what are called join operations, right?
Yes, and as your data scales, those join operations become computationally heavy. The database practically sweats trying to cross-reference millions of rows just to find a single connection.
Right. It takes forever. But a graph database like Neo4j, the best way I can picture it is like a detective's crazy wall. You know, the ones in the thriller movies with the photos pinned to the corkboard and the red string connecting everything together?
The crazy wall is the perfect mental model for how a graph database stores information.
So in this system, the nodes are the photos pinned to the wall. They get labels like person or project or document.
Yeah.
And the edges are the red strings physically connecting them, and those strings are labeled with the verbs we found earlier, like works on or mentions.
Exactly.
And the sources note that Gemini also generates descriptions and tags for these nodes, so each photo on our crazy wall basically has a detailed dossier attached to it.
And the reason we build this elaborate crazy wall instead of just using the filing cabinet is purely about speed and traversal.
How so?
Well, in a graph database, the relationship isn't something the system has to calculate on the fly by cross-referencing tables. The red string is explicitly drawn and stored.
It's already there.
Exactly. If you want to know who works on the project, mentioned in the document that Alice authored, the system literally just walks along the red string from node to node. It is an architecture built from the ground up to traverse complex relationships instantly.
Which brings us to the most important question. We have this beautiful, massive detective's wall. It's organized, the red strings are everywhere, the nodes are tagged, but, nobody just builds a crazy wall for decoration.
And let's hope not.
How do you actually use it? This brings us to the query layer and how this architecture completely revolutionizes a concept called RAG.
Ah, yes. RAG stands for Retrieval Augmented Generation. But before we get into how the graph changes it, we should probably define what standard RAG looks like.
Please do. Because RAG pipeline is like the biggest buzzword in enterprise tech right now.
It really is. At its core, standard RAG is basically giving an AI an open book test. Instead of just asking a chatbot a question and hoping it remembers the answer from its training data, a RAG system first takes your question, searches your company's database for relevant text chunks. It retrieves them, and then feeds them to the AI alongside your question. It basically says, read these specific documents and then answer the user.
Which sounds great in theory, but standard RAG has a massive flaw when dealing with complex enterprise questions, right? It still hallucinates or loses the thread if the answer requires connecting dots across 5 different documents.
Yes, that's the limitation. Standard RAG usually relies purely on vector search. Gemini takes your data and generates what are called embeddings, specifically 768 dimensional embeddings for each node.
Okay, let's ground that concept real quick. 768 dimensions sounds like science fiction.
That's a lot of math.
For anyone who isn't a machine learning engineer, you can just think of an embedding as a highly complex mathematical coordinate. It turns a concept like a document about a software bug into a specific location on a massively complex 768 dimensional map.
That is a fantastic way to visualize it. And the AI uses those coordinates to measure how close or related two ideas are. That's semantic search. It is fantastic for finding related themes or the general vibes of a question. But vector search struggles with explicit, multi-step facts.
And here is where the crazy wall changes the game. Vector search finds vibes, but graph traversal is about hard facts. Explicit, undeniable links, like Alice owns Project X.
Exactly.
So by combining them into a graph rag system, we are basically giving the AI both human intuition through the vector coordinates, A and D, a perfect photographic memory of exact relationships through the graph's red string.
And that combination is the superpower. It effectively eliminates the hallucination problem.
Let's use the concrete example from the sources to show how this works sequentially. Say I ask the system a complex question like, who is the owner of Project X and what milestones are overdue?
Okay, if you just use standard vector search, the AI skims the text based on mathematical proximity. You might find a document that mentions Project X, an owner, and some milestones, but it might jumble up who actually owns what, because it's just guessing based on text proximity.
It's just guessing the vibes.
Right. But with a graph-powered RAG system, it's a two-step process. First, the AI uses the vector embeddings to understand the intent of your question and locate the right neighborhood of nodes on the wall.
It finds the photo of Project X.
Exactly. Then, step 2. It physically traces the explicit red string from the Project X node to the person node connected by the owns edge.
Oh.
Then it follows another red string to the milestone nodes connected by an overdue edge. It fetches the exact undeniable facts through traversal. Finally, Gemini takes those hard facts and generates a natural conversational answer for you. It's verifiable intelligence.
That is so cool. So what does this actually look like in the real world? We understand the theory, the extraction, the chunking, the deduplication, the crazy wall, but who is actually building this and what is the return on investment? Let's talk about the real-world pipelines mentioned in the sources.
The ROI for building these custom pipelines is staggering. The sources highlight several use cases. For instance, there's a company called Glance using Neo4j as their graph backend.
What are they doing with it?
They are feeding raw articles and live user interactions into their extraction layer to map out industry trends and provide real-time recommendations.
Wow. There was also a mention of MLOps pipelines. And before you dive into that, MLOps basically stands for machine learning operations. It's the plumbing and infrastructure required to keep AI models running smoothly in production.
Yes.
The sources noted that MLOps pipelines using Gemini and a database called ApertureDB to build knowledge graphs are speeding up enterprise customer issue resolution by a massive 30%.
I mean, a 30% reduction in resolution time is a monumental shift for any support center.
It's huge.
It means a customer service agent isn't desperately digging through that mountain of chat logs and wikis we talked about at the very beginning.
Right.
They type in the issue, and the graph instantly surfaces the user, follows the red string to their past tickets, traces another string to the underlying product documentation, and points directly to the known solution.
But there is a massive fork in the road here that we need to clarify for the listener. Everything we just talked about, using Neo4j, spanner graph, building custom MLOps pipelines, that is the custom-built route.
Yes.
But the sources also made a very clear distinction regarding Gemini for Google Workspace, or what's sometimes called Gemini Enterprise, because Workspace actually has a knowledge graph built right into it.
It does, and it's vital to understand the architectural difference there. The Workspace graph is internal, pre-wired, and fully managed by Google.
Okay.
It is specifically designed to link people like your company org chart with content, like your Google Docs, Drive files, and emails. And it automatically maps interactions, tracking who collaborated with whom and when.
Right. It powers features like that internal people panel where you can hover over a name and instantly see their manager, their teammates, and the shared documents they're currently working on.
Yes, exactly.
So, if I'm summarizing this choice for you listening, if you just want to know who your coworker emailed about a specific presentation last Tuesday, the built-in Workspace graph is like renting a fully furnished apartment. It is ready on day one. The lights are on, the plumbing works, the furniture is already arranged.
But you can't tear down the walls or build an extension. You are locked into their structure.
Exactly. The pre-built graph only knows about emails and docs. But if you are a company like Glance and you need to map out massive proprietary industry trends, or you want that 30% boost in customer support by mapping your highly specific product architecture to thousands of user support logs,
Then you don't rent the apartment.
right. You build your own custom house using a graph database like Neo4j, and you fuel it yourself using the Gemini API.
That is the core architectural decision every enterprise has to make right now.
Yeah.
Are you just trying to map your internal employee collaboration, or you're trying to mathematically map your core business domain.
Yep.
If it's the latter, the custom Gemini extraction pattern is what allows you to turn your unique, unstructured chaos into a highly proprietary asset.
And bringing it all back to you. Whether you are a tech leader trying to figure out how to shave 30% off your support resolution times, or you are just a curious learner trying to wrap your head around where data architecture is heading, the real takeaway here is a fundamental shift in perspective.
A huge shift.
For the last few years, we have focused on AI's ability to generate text or write emails or create images, but the true power of AI in the enterprise is its ability to structure knowledge.
Yeah.
It is about turning the impossible haystack into an organized map.
We spent so much time treating AI as a conversationalist, but its deepest, most lasting value is as an architect of information.
Which leaves me with one final, slightly wild thought to mull over, building on everything in these sources. We just spent this entire deep dive talking about Gemini using its 768-dimensional embeddings and its probabilistic deduplication to build these massive, perfect maps of enterprise data.
Yeah.
Right now, we are the ones using these maps to answer our own questions. We ask about Project X, the AI traverses the red string, and it gives us the answer. But what happens when these knowledge graphs get so incredibly vast and so deeply interconnected across millions of nodes that the AI starts discovering things no human in the company even knew existed?
Oh, that is exactly where the frontier of this technology is heading.
Right. I mean, what happens when the AI looks at the billions of red strings and spontaneously points out massive operational bottlenecks, or identifies hidden expert networks within the company where two completely separate departments are solving the exact same problem without realizing it?
It's going to happen.
Or finds product relationships that were completely invisible to the human eye. If the AI is the one building the map, at what point do we stop using it just to answer our questions and start needing the AI just to help us comprehend the very map it built?
It represents a total paradigm shift. The tool evolves from being a simple search engine into a proactive discovery engine.
And suddenly, that terrifying digital mountain of messy data doesn't look like a headache anymore. It looks like an untapped goldmine. Thank you for joining us on this deep dive. Keep questioning the systems around you and keep connecting the dots in your own world.